In this lesson, we're going to be talking about equations as relations. By the end, you should be able to determine the range given the domain and graph the solution set for a given domain. An equation relation is simply any equation that contains two unknown values. Those two unknown values are going to be represented by variables, typically x and y, which represent an order pair. Your equation relation is something that describes a relationship, such as y equals 2x. This type of relationship is, for this particular example, this is a relationship that is linear and has a slope of 2. Remember that we have other types of functions or relationships that can be represented by equations, such as quadratic equations and exponential equations. When we talk about equation relations, we use them a lot of times to identify our possible values in a function or in a relation, and we call that a solution set. A solution set are all of the ordered pairs that make the statement true. Sometimes we're listing the solution set individually, and sometimes we're using an inequality to describe that. Answers that do make the statement true, we're going to list them in set notation, and we're going to put them in what's called braces. Now, when we are listing out our solution set, we're going to split it up into two groups. The first group that we're going to split it up into is our domain. These are all of the independent values. Remember that they do not depend on anything else. So they aren't changing because of anything else that you're looking at. These are going to be all of your x values. And if you're using a different variable other than x, make sure that that variable is first alphabetically. Time is going to be your independent variable. A lot of times when we're looking at word problems, it's something over time. So time would be the independent variable in this case. You're going to begin to see what we call function notation. So instead of seeing something like x equals 4, what you're going to begin to see is f of 4. What this is saying is take your function and evaluate it for x equaling 4. So that f of x part, the x on the inside, is the x equals part. When you're listing your domain, remember, make sure that you're listing it in order from least to greatest, and you don't need to repeat any values. So if you have multiple values that are the same in the domain, you're only going to list it once. The second group that you're going to have when you're listing your solution set is your range. These are the dependent variables. These are the ones that are changing because of the independent variable. So for example, in the soda machine, the soda that comes out changes based off of the button that you press. These are going to be your y values. So these are going to be all of your y values. So when you're looking at a graph, you're looking at your set of y values. Quantity is typically going to be your dependent variable. Remember that we're looking at something over time. Time is the independent, and quantity is going to be your dependent variable here. Y in this case, so this is where you need to kind of pay attention, because we talked about f of 4 meaning x equals 4. The f of x, the whole thing, so the whole f of x itself is y equals. So if you have f of x equals something, so if you had f of x equals 4, then that would be y equals 4. So kind of know the difference between those two things. Again, when you're writing range as well as domain, you're writing them in order from least to greatest, and you're not going to repeat any of those values. Okay, one of the things that we want to be able to do is we want to be able to write the equation given a relation. So here we have the relation that's in a table. We have the x values of 1, 2, 3, 4, 5, and we have the y values of 3, 6, 9, and then we have some that are missing. What you want to do is you want to look for a pattern. So we see the x's are increasing by 1s here, and it appears that the y's are increasing by 3. So if we continue that, this would be 12, and this would be 15. We want to be able to explain this pattern. So we want to be able to see, okay, so from x, how are we getting to y? And so we see that if we do 1 times 3, we get 3. 2 times 3, we get 6. And 3 times 3, we get 9. 4 times 3, 12. 5 times 3 equals 15. So what we see as the pattern is to get the y values, we take the x's and we multiply them by 3. So your equation for this one would be y equals 3x. Now, aside from being able to write the equation for a relation, we want to be able to identify solutions when we're given an equation. So here we're given the function y equals 3x plus 3, and we're given some points. We're given negative 2, negative 1, negative 1, 3, 0, 4, and 3, 9. We want to make sure that these are solutions to our function. So if we substitute in the first point of negative 2, negative 1, putting in the negative 1 for y and the negative 2 for x, this is what we'll end up with. We'll replace each of those. We'll have 2 times negative 2, which is negative 4, negative 4 plus 3, which is negative 1. And so we see that negative 1 is equal to negative 1. And so we do have a true statement here that this is an actual point in our function. If we try the next point, so if we try negative 1, 3, again substituting in those values, putting the negative 1 in for x, the 3 in for y, and we evaluate it. 2 times negative 1, which is negative 2, negative 2 plus 3, which is positive 1, and that is not a solution because what we should have gotten out is 3. If we continue to try those points, we'll see that the third one also doesn't work, but the last one does work. And so we see that these middle two are not solutions, but the top and the bottom one are. And so what we want to do is we want to list our domain. So from our solutions, our domain is negative 2 and 3. So we would list negative 2 and 3 in numerical order. And for our ranges are negative 1 and 9. Again, in numerical order from least to greatest. Other than being able to identify if points are solutions, what we need to be able to do is generate points that are solutions. So if we take a given domain, whether that domain is given to us or whether we make that up on our own, we should be able to put in those x values and get out a y value. So here we have a domain that's given, so we have negative 1, 0, 2, and 4. So our domain for this function is going to remain negative 1, 0, 2, and 4. What we want to do is we want to put in our domain. We want to substitute in those values for x. So if we substitute those in, each of those points would be represented by x here. And then we evaluate it. So this first one, we have 5 minus 2 times negative 1. Remember, order of operations says to do the multiplication piece first. Make sure that you include this minus sign here. Okay, it's going to attach itself to the 2. It also means negative 2. So negative 2 times negative 1, which is positive 2, and 5 plus 2 is 7. We have 0 here, so that would be 5. Negative 4, so that would be 1. And negative 8, which would be negative 3. So here we have our points. Negative 1, 7, 0, 5, 2, 1, and 4, negative 3. And again, listing our range, make sure that you're putting them in order from least to greatest. Negative 3, 1, 5, and 7. When we start, again, looking at this part, this is that same thing. We're given our domain of 0, 1, 2, 3. But what you're going to see in this particular one is because of this absolute value. Remember, absolute value meaning that the values are all going to be positive. What you'll see is we have some y values that repeat. So we have the 2 and the 1 that are repeating. When we're listing our range for this particular equation, the important thing to note here is that we're only going to list the 1 and the 2 once. So our range would be 0, 1, and 2. There's no need to write it multiple times because we're just checking to see if we're just trying to see what our ranges are, what values are in the range. Okay, writing the function rules from words. Make sure that you're reading carefully. This less than right here is going to put the 8 behind. So it's saying take everything that you have and then make it 8 less than that. So if we have a third of x, 8 less than that would be 1/3 x minus 8, and then that equals y. 12 more than, the same thing. The more than says do whatever you got to do first and then add on. So we're taking the quotient, which is division of t and 7, and then we're adding 12 to that. Again, this price per pizza, you're starting with $7.95 plus you're adding 75 cents per topping. Then Eric is 2 years younger than twice his sister's age, so you take twice his sister's age, you subtract 2 from that, you'll get Eric's age, and if his sister's 11, then Eric would be 20 years old. Okay, before you watch the next video, one thing that I would like for you to consider is what that f of 4 wants you to do in function notation. So what is that actually representing? What does it mean? Hopefully you found this video helpful. Please subscribe to the channel and join us in the next video.